I'd like to show you how to interpret the solver sensitivity report for a linear programming problem. So what we have here is the Flare furniture problem from chapter 7 set up. What I'm going to do is I'm going to solve it. Note, by the way, that this is the dialog for Excel 2010. For 2007, it looks a little bit different. Make sure that you check that it's a non-negative, that you want non-negativity, no non-negative solution. I have to select the simplex LP method, but this is automatic in 07 if you check the linear problem or linear solution in options. The key, however, has to be that you have to select the sensitivity report, and that produces a separate output, and that's what the sensitivity report looks like. So let's go take a look at what each of these items means. So first of all, those two columns here, or those two cells here, indicate the final value, the optimal solution. So optimally, we need to produce 30 tables and 40 chairs. The final value for our constraints that we're going to use for the solution, 240 carpentry hours and 100 painting hours. And notice that it also puts down the constraint right-hand side, which is the available resources. So we have available to us 240 carpentry and 100 painting hours. Since the final value and the constraint right-hand side are the same, it means there is no slack. That means we're completely using all of the available resources. Now let's talk a bit about this set of cells here for shadow price. So shadow price basically means that you can use that to determine how your solution would change, particularly how your objective function value would change as you obtain additional units of your constraints. So instead of the right-hand side having been 240, what would have been the case if it had been 241? Let's go back to the previous sheet here. So suppose that instead of having a right-hand side of 240, we had a right-hand side of 241. How would that affect our objective? In other words, what would the new profit be if we had one additional unit of carpentry hour available? Well, instead of rerunning the solution, we can simply look at the solver output. This value right here tells us exactly what the effect would be on our objective. So this shadow price, also called dual price, means that for every additional unit we get of this constraint, so if it goes from 240 to 241, from 241 to 242, for every 1 unit increase, your objective function will increase by 15. So in this particular case, if we get 1 additional hour of carpentry time, we would be able to realize an additional profit of $15. Now we can use that shadow price for increases of up to 60 units, because the allowable increase is 60, which means we can increase from 240 to up to 300, and we would get the new profit without having to rerun the model. So for example, if I go from 240 to 250, that would be a 10 unit increase, which basically would mean that my profit would go up by $150. It's an increase of 10, which is still within the allowable increase range. Similarly, if I reduce my constraint from 240 to 239 hours or 238 hours, for every 1 unit I decrease it by, it will reduce my profit by $15. It will basically change my objective function by 15. And I can do this for up to 40 units downward. So my allowable decrease is 40. Similarly, for the painting constraint, for every 1 additional unit of the painting constraint I get, my objective will increase by 5. For every unit I reduce it, up to 20, my profit or my objective will be reduced by 5. So I don't actually have to rerun the model. I can simply read how my objective changes from the sensitivity output. In fact, let's go try this out. Suppose I had gone ahead and changed it to 241. Right now my profit is 4,100. I changed my right-hand side from 240 to 241. I'm going to rerun solver. I'm not going to this time select an output. And notice what happens. It goes up from 4,100 to 4,115. Now, of course, I could rerun the model, but I don't have to do that. I could have simply read that potential increase by looking at the sensitivity output. So this is very useful because it allows you to play with what-if scenarios. There is an alternative. The second part to this, which is reduced cost, which basically means that's the cost or additional profit, if you will, for every additional unit you produce of that. Now, of course, we are at a maximum here. We have used all allowable resources, so we have no reduced cost. But if there was a reduced cost of, let's say, $10, just for the sake of example, I know it's not there, but just for the sake of example, it would mean that for every additional unit, in this case tables, every additional table produced, our profit would increase by $10. But please keep in mind that this was originally zero. There is no reduced cost because we are at a maximum. So that is how you need to interpret the solve for sensitivity output. A couple things to keep in mind. Make sure that you only use the sensitivity output for this range, which means you can go up as much as 60, meaning from 240 to up to 300, and down as much as 40, meaning going from 240 all the way down to 200. So you can basically estimate your objective in the range of 200 to 300. Anything outside that range would require that you rerun solver, that you basically go back to your original sheet, update your parameters, so let's say 400 hours of carpentry and 500 or 300 hours of painting, which fall well outside the range of the sensitivity report. That would mean we would have to rerun solver and really get the actual solution, which in this particular case would be now 100 tables and no chairs. What's interesting, by the way, is that you now have no slack for the carpentry constraint, but you do have a slack of 100 for the painting constraint. Let's go take a quick look at solver and see what that would look like for solver in the sensitivity report. You would notice, by the way, here right now, I would have no slack here and a slack of 100 here. Notice also my shadow price, that's the additional profit I could realize with the increase in the objective function for every additional unit. Notice you only get a shadow price if there is no slack, if the constraint is binding. Remember, you call a constraint that has no slack a binding constraint. Also look at the reduced cost. This is not a reduced cost or they change the objective function if you produce an additional unit of that particular item. So if you produce a chair, if I go and produce one chair, that would change my solution by minus 2.5. It would mean that I actually would drop my profit by $2.5. And of course, that's expected because we have, there's an ideal solution, 100 tables and no chairs. So that's how you interpret the solver sensitivity output.